Alright, so in this video we're going to make one full example of how to find the critical points and to figure out what the maxima and minima, and we'll save this another type of critical point called the saddle point for another moment. So let's first focus on solidifying the first concept and then let's moving forward. But so before going to the actual example, just from the previous videos we covered the topic of what a critical point is, which is in a sense what happens when you equalize the derivative to 0. The f prime of x would be equal to 0, and that's the points to figure out to comply with this condition would be the critical points. There are three types in a sense, which is the maxima, minima, which we already seen examples of them, and there is a third one, which is a saddle point that we'll save for later. Okay, so pretty much what we got to do, we start with a function, and we are going to figure out its critical points, figure out whether the maxima minima, and then we're going to add something new. Let's sketch at the graph out of this function using these critical points, so this information that we can find through derivatives. So first thing is pretty simple. We take the derivative out of this expression, would be here 18 times x minus 6 times x squared, and then we equalize this guy to 0. This 0 equal to 18 times x minus 6 times x squared. Then let's see, I'm going to factorize here the 6 times x, and we got here to be 3 minus x. So we got here in a sense two critical points. The first one would be 6 times x equal to 0. We divide both sides by 6, and we got that x is equal to 0. Here we got our first critical point. This is the critical point. And then we do the same with the other guy, which is 3 minus x equal to 0. So in a sense, will be 3 equal to x, and this is how we got our second critical point. This function provided not one but two critical points. So I'm going to actually this is our critical. These two guys are our critical points. And there it is. Okay. Now let's figure out whether if they are maxima and minima using this criteria that we studied in the previous video. So I'm going to sketch the line and locate both of these guys, the 0 and the 1. So here for the 0. Here I'm going to locate x equal to 0. And here I'm going to locate the other one, x equal to 3. There it is. Now let's make a test. I'm going to use, let's say, I'm going to pick a value for testing in a derivative before the x equal to 0. Let's say I'm going to pick f equal to -1. So f equal to -1 would be, well, I'm just going to substitute here the -1 on that derivative. There it is, and we got here, this would be a -18 minus 6, and we're going to get here a -24. Now this -24, the only thing that actually matters is the sign of this output, which is telling us that this is descending. So the function is descending up to a point that it reaches the x equal to 0, and after it, let's see what happens. After it, let's pick a value. What could it be? Of course, the 1, I think, would be the simplest. F prime of 1. So this should be on the derivative, of course. We got to evaluate on the derivative. Let's keep that in mind. And so it would be 18 times 1 minus 6 times 1 squared. We got here 18 minus 6. And we got here, of course, a positive value, which this represents the function is between 0 and 3, would be ascending. Then after the 3, let's pick a value of the 3 on the derivative we're going to evaluate. Let's say f prime of 10, and we've got here would be 18 times 10 minus 6 times 10 squared, and we got here would be 180 minus 600, and of course we get here at the end 420. And this is this is a negative 420. I'm sorry, it would be negative 420. And this is a negative value, so this is representing that the function after the 3 would be descending. Now, so if the function then is regarding the x equal to 0, before the 0 it's descending, and after the 0 it's ascending, this has to be, of course, a minima. This has to be a minima. Now, regarding the x equal to 3, well, the function it would be ascending, and then descending. So, in other words, this has to be a maxima. There it is. So, it's pretty much what we have been doing previously in the previous videos. Now let's add something new. I'm going to sketch the graph of these values, but in order to sketch the graph, it would be very wise and very nice to figure out where exactly are these minima and maxima. That is to say, I'm actually going to write it. Would be nice to say where are these critical points? Where are the critical points? In other words, we are asking for the coordinates of these points. So in order to figure out where are these points, well, to figure out where the coordinates are, which coordinates are, so we got to evaluate on the function, on the f of x. We evaluate here to figure out where exactly are located these 2 points. So the f of 0 will be 9 times 0 squared minus 2 times 0 to the third, and f of 0, of course, this will be equal to 0, which in other words is telling us, well, we got a minima at the point 0, 0. We figured this out using the f of x. Just be sure to remember that we're using the f of x, not the derivative of it. To locate the coordinates, we use the actual f of x. Now, for the other point, the f of 3 will be 9 times 3 squared minus 2 times 3 to the third, and it will be f of 3, of course, will be here 9 times 9 minus 2 times 27, and we get here to be f of 3 will be equal to a 1 minus 54. So f of 3 will be at the end positive 27. So in other words, this maxima, we have this maxima at the point 3, 27. Well, with these points, I mean, we got these points of this information. Now it would be pretty easy just to sketch a graph. We have something pretty, let's say I'm going to sketch something like this, something simple. Well, let's say we got this super nice or not so nice graph. We got a point, a minima at 0, 0, and then we got a point, another one, 3,27, somewhere, let's say around here. And then we got the idea that this descending, I'm going to actually use this other color, will be here descending. When it reaches the 0, 0, then we start ascending. It reaches the x 3,27, which is this point, and then we'll start descending. And that will be pretty much actually the graph for you. I will show you just this the graph on the Desmos. Here it is. It's a graph from Desmos. I think you can see it here. It's pretty much the idea of the graph. Here we got the point 0, 0, which is this minima, and we got the maximum 3,27. So well, that's pretty much it for this example.